Hello, my name is Kshitij Nikhal, and I am a graduate student from the University of Nebraska, Lincoln. In this work, we introduce an unsupervised, attention-based, instance discriminative learning for the problem of person re-identification. The objective of re-identification is to retrieve instances from the gallery corresponding to the same subject as the query, amid occlusions, wearing pose, poor localization, background clutter, and clothing variations. The query image could be of low or high quality and can be constrained. Example, a driver's license or a passport photo, or it could be from a surveillance camera. It has important applications in intelligence, defense, and security. We propose a new unsupervised framework, a new grouped attention module, and a joint objective function that achieves state-of-the-art results on 2 datasets, and we also perform some analysis on them. Group convolutions have been used to distribute the network in the AlexNet paper and the ResNext block. Hierarchical clustering have been used in bottom-up clustering, and attention has been trained in a supervised way in the harmonious attention CNN and the convolutional block attention module. However, unlike previous methods, our attention is learned in a completely unsupervised way. Our fully unsupervised framework consists of 3 main components: the grouped attention module, the instance discriminative loss, and the agglomerative clustering loss. The original and augmented images are fed to a ResNet 50 based architecture with grouped attention modules to generate the feature embeddings phi. These feature embeddings are clustered by the guidance of instance discriminative and the clustering loss. The proposed attention module works by summarizing activations of the previous layer. Here, the first feature map is first pulled over the spatial dimensions and then fed to a subnetwork to produce channel attention. The channel-refined feature map is then pulled over the channel dimensions and passed to a convolutional layer to produce the spatial attention. Our instance discriminative loss works by maximizing the probability that the augmented instance x sub I hat is classified as the original instance x sub I, while minimizing the probability that other instances x sub j in the batch are classified as x sub I. To further improve discriminative capabilities, our framework merges instances into clusters in a bottom-up manner. Initially, each image is its own cluster, and the probability that image x sub I belongs to a cluster beta sub I is maximized. At each iteration, the embedding phi is optimized using stochastic gradient descent, and the optimized representation is used to update the memory bank. Each singleton cluster is merged together according to a dissimilarity metric using the feature embeddings phi. A balancing term is added to the metric to avoid mode collapse. We see an improvement of 2% in rank 1 accuracy and 6.1% in mean average precision scores over the previous state-of-the-art BOC using pre-trained ImageNet weights. We also see a significant improvement in rank 1 accuracy and MAP scores without using pre-trained ImageNet weights. And similar experiments were performed using the Duke image-based dataset. Because of the use of grouped convolution, the complementary attention maps generate better attention by learning filter relationships in a more structured way. Our method correctly focuses on the person and ignores background clutter without using any kind of labels. It also shows the benefit of using unsupervised attention. This figure shows the query image in the center and the corresponding top retrievals around it. As is evidence, BOC retrieves many similar but false positive identities, while our approach retrieves very different cross-camera views but the same identities. In conclusion, our combination of grouped attention module, instance discriminative loss, and agglomerative clustering loss outperforms all methods on 2 large-scale image-based datasets. Thank you.